Welcome to Making Stuff with Chris Dayhut and our segment titled This Maker's Tools. For today's tool, we are looking at the magnetic base, which is a tool that holds a dial or dial test indicator securely in any orientation, and that makes it very useful in machine shops when you're performing setups or doing inspections. You will hear it often referred to as a mag base, or short for magnetic base. Frankly, I think that is the more commonly used name for it than its true name, magnetic base. To the best of my knowledge, these devices were originally designed to hold these dial indicators or test indicators for use in machine shops and primarily with an inspection. However, they've been further modified or applied to many other purposes throughout time. Simple examples would be to hold cameras in position, or to hold a shield that you would have on a machine that you could reposition to protect you from flying chips. Lights are often also attached to these, especially some of the smaller LED lighting. That way you get task lighting exactly where you want it, and it's held fairly securely. But for today's purposes, we're going to focus more specifically in their machine tool use and inspection use. Here are a few examples of magnetic bases that I have, and I think these will be very adequate for telling the story that I need to tell here. This particular style is probably the original style that most people were familiar with going back 50 years or so. It has two stems. The main one coming out of the base is rigid mounted, and then you have another stem that can pivot on this, and it can be moved by, if you turn it the right way, it'll loosen. You can move it up and down and pivot the arm. The problem with this was that it really helped secure everything, allowed you to get things in position, but it was very limited in how you could do that. And you ended up with some real crazy contraptions on the different clamping knobs to get the indicator or the device in the orientation that you wanted. And these are also the most economical ones. This particular unit I've only included here because you'll see I got another one identical to it. This was a very economical version of this. And this particular one, it does have a brand name, but I'm quite certain it was manufactured in China and it was made to be economical. You can get these at a reasonable price, but you got to be prepared they won't perform nearly as well. But the design difference between this style and the previous one, the main stem is on a pivot. And you can pivot this thing all the way over to 90 degrees. You can rotate any which way you want. From arm 1 to arm 2, you have a pivot joint. And then finally, up near the clamping unit, or the holder as it's more commonly called now, you can swivel that around and turn it as well. All of these pieces clamp with the rotation of just that one knob. Where this one fails miserably, that clamp does not always clamp all the joints securely. So you end up with movement when you're trying to use it. And in most cases, that renders it useless. The clamping unit or the holder has a very terrible fine position adjustment and a terrible clamping mechanism. So it's just a cautionary statement with this. There are cheap ones, but be prepared to not only pay for it, but be frustrated with it. Finally, we will get to this unit, and this one is my favorite one. The brand is Noga, N-O-G-A. I'm not sure if I'm pronouncing that right, so please verify that, or if you know the correct pronunciation, please put it in the comments below. I've only been using this style for the last 30 years or so, 20 years, so you would think by now I would know the brand name and how to pronounce it better. But it's got the same features, a single arm. You've got all the swivel, pivot, and turn capability and rotational capability as that more inexpensive one. But the nice part about this, when I securely clamp that knob, everything holds position while I'm using it. That is critical. Furthermore, the holder has a very good fine adjustment for very precisely positioning the dial indicator or the regular dial indicator or the dial test indicator as you're using it. And then the clamping mechanism, very fine, very precise, has capability to clamp the large stem indicators as such, as well as smaller stem versions in that hole, and then it has the dovetail clamping mechanism. And I'll show you that. And then that's held in there very securely. Now, those are the basic, bare minimum features of a really good magnetic base. Now, the last thing that I haven't even talked about, which really defines what it is the base. It's magnetic. You can turn the magnet on and off by rotating this. All it does is position a magnet internally to line up at the base. So you put it on your machine or your table, whatever it is, as long as it's ferrous, lock it, and it'll hold it very securely. Let's hop onto the Noga website, and I'll quickly go through with you some of the systems, and you'll notice different variations. Like on this particular model, there's an adjustment here that allows you to perform fine adjustment of the whole arm's position. Now, they come in different varieties, different configurations for different applications. Now, as mentioned, there are the three components, and we'll start by looking at the bases. This is the variety of bases that they offer in different sizes, different adjustment capabilities, and different holding strengths. There are also some that are non-magnetic, such as a vacuum base or these clamping units that would clamp onto a steel, and then they have optional non-marring plastic covers. From there, you would pick out your arm, and boy, there's a wide variety of those. And this particular one here, the 310, is very similar to the one I've got that I was showing you on the bench. Its arm length is 180 millimeters on arm 1, and then arm 2 is 130 millimeters. Has an M8 by 1.25 internal thread for the clamping unit or the holder at the top, as well as to screw it into and fasten it to the base. But here's the interesting thing. Maximum load for this particular model, 25 kilograms. For those of us here in the US, that is basically more than 50 pounds. Very impressive how powerful and good that is. Then you'll get into the clamping heads, or holders, as this manufacturer calls them. And there's some very basic ones that just can clamp with a very minimalistic fine adjustment. Notice these are plastic. You get into more elaborate systems, and this is my favorite type and the type I have on mine. Then you will see some other contraptions to hold other devices on a Noga base. And that's where this device started branching out and being applicable for many other purposes besides holding dial indicators. So that you have an idea of price range, this particular unit that I was showing you, my favorite one, is $99.74 US, with apparently it has a 5% off discount today or something. But that'll give you a ballpark range for what these things cost. Now that you've got an idea of what a magnetic base is, how much it costs, what makes one good or bad, and the different features of it, let's just take a quick moment to show you how it's used in a few applications. For this demonstration, I have a ground shaft chucked up in a collet in my spindle. The mag base is attached to the machines table, and the arm has the indicator positioned perfectly at the high point of that shaft. The purpose of this, as I rotate that shaft or the spindle, I can monitor how much run out there is in either my collet or in the spindle. For this demonstration, I need to make sure that the master jaw of my vise is perfectly aligned with the x-axis of my mill, and that is this axis. So to do that, I needed to attach the mag base up on the headstock somewhere. And one of the convenient places for this particular setup is right there on my spindle quill. Attached it there, adjusted everything so that my indicator would be right here and set to 0. And it's in a nice comfortable position to read it as I'm moving the x-axis along. Now that the indicator's all aligned, I'll just hand wheel the table across and look for any needle movement on the indicator. And with that, I know the vise is parallel to the x-axis of the table within less than 1/1000th of an inch. Now, as you can imagine, in your situation, if you don't have a machine, you may not have a good purpose or application to have a magnetic base. And that's, hopefully you understand that. But keep an open mind. This isn't a tool specifically for machine tools. Like I said earlier, you can use this to hold different devices such as a shield, a camera, a light, and that can be very handy in your shop even if you don't have a milling machine. Well, that should do it for today's video. Hopefully you've got a little more understanding of magnetic bases and their applications. If you enjoyed this video, I would greatly appreciate it if you could give me a thumbs up, subscribe if you haven't done so already, and more importantly, if you got a question, feel free to ask it in the comments section below. Thanks for watching, and I look forward to seeing you next time.